this video, we're going to see 3 examples of the easiest simplification of square roots, which is finding the square root of integers. The first case, what is the square root of 9? I want to find the square root of any number. What I want to find is what is the number that when squared, that is when multiplied by itself, equals the radicand, the number that is inside of the radical sign. In this case, the radicand is the number 9, and the square root of 9 is the number 3, because 3 multiplied by 3, or same thing, 3 squared equals 9. But you may have noticed that there is another number that when multiplied by itself also equals 9. That is the number negative 3. So negative 3 multiplied by negative 3 also equals positive 9. So why is the answer the positive 3 and not the negative 3, or both? The truth is that both 3 and negative 3 are roots of the number 9. But it is implied, you see this sign right here, the radical sign, that we are asking for the principal root. And what is the principal root is the positive root. So the real question that we must ask when we see this symbol with a number on the inside, it is, what is the positive number that when multiplied by itself equals the radicand, number inside of the radical sign? So, to answer the question correctly, what is the principal root of the number 9? The principal root of the number 9 is positive 3. If you want to find the negative root of the number 9, you have to write it this way. You have to put the negative number the outside of the radical sign. This way, what you're saying is, what is the principal root of the number 9 multiplied by a negative? This is the same as if you were multiplying it by a negative 1. So, the answer to this is positive 3, negative on the front, which means negative 3. This is the way finding the negative roots of the number 9. What is the square root of 125? I can rewrite the 125 as 25 times 5. Now, there is a property on square roots or any kind of root where you have two numbers being multiplied together in the radicand, that is inside of the radical sign. You can separate them into two radical signs being multiplied by each other. For example, if I have 25 multiplied by 5 in the radicand, I can rewrite that as the square root of 25 multiplied by the square root of 5. So when I do this, what this allows me to do is to find what is the principal square root of 25. Principal square root of 25 is the number 5, positive 5. The square root of 5 is not an integer, so I am not going to change it. I'm just going to leave it as the square root of 5. So what I find out at the end is that the square root of 125 equals 5 multiplied by the square root of 5. And I don't have to write the multiplication sign. It is implied when you write it this way that this means 5 multiplied by the square root of 5. And that is how you simplify the square root of 125. Another example, we see what is the square root of 9,000. Again, I start to factor it. 9,000, I can rewrite it as 9 multiplied by 1,000. Then again, I can rewrite the 1,000 as 100 multiplied by 10. So in the end, I find that the square root of 9,000 equals, using the same property that I used before, square root of 9 multiplied by the square root of 100 multiplied also by the square root of 10. Now, the square root of 9, we saw earlier that equals 3. Square root of 100 equals 10. 10 squared, 10 multiplied by 10 equals 100, so the square root of 100 equals 10. The square root of the number 10 is not an integer. Therefore, I'm not going to change it. I'm just going to keep it as the square root of 10. And what I can do now is multiply the number 3 times the number 10, and I get 30. So, the end, I do not have to write the multiplication sign, and I can just simply say that the square root of 9,000 equals 30 multiplied by the square root of 10. Over 9,000 simplifies to 30 times the square root of 10. And the last example, and what is the square root of 1 million? 1 million seems like a huge number. It seems like it's going to be a very difficult problem, but it's actually the easiest one that we're going to see today, because you can rewrite 1 million as 1,000 multiplied by 1,000, and that is simply 1,000 squared. And when you have a number in the radicand, a number inside of the radical sign with an exponent, exponent is the same number as the grade of the root. Remember that a square root is a root of grade 2. So I have a root of grade 2 and a number or a variable exponent 2. If I have a number or a variable an exponent that is the same number as the grade of the root, that simply equals that number of that variable. Example, the square root of x squared simply equals x, and the square root of 1,000 squared simply equals 1,000. So, the square root of 1 million equals 1,000. Remember, million, I can rewrite it as 1,000 times 1,000, which is the same thing as 1,000 squared. The square root of anything squared, variable or number, is simply that number. The square root of 1,000 squared is simply 1,000. The square root of 1 million is 1,000. Now, in this series of videos, we are not going to talk about the square root of negative numbers. Those numbers, the square root of negative numbers, are called imaginary numbers. And when you combine real numbers with imaginary numbers, you get complex numbers. So I'm just gonna say that we are not gonna be working this series of videos with negative square roots. But when we discuss imaginary numbers and complex numbers, we can see a lot of videos, the square root of negative numbers and imaginary numbers and complex numbers, and do a lot of maths with those complex numbers.